Welcome to Brain Vision.
We're going to evaluate this system in two instances. So the first instance, we have a mass, and essentially there isn't any, the spring isn't compressing at all, and it's not being stretched at all. So it's at its equilibrium, and we have a force of wire a force of wire B, and then we have here force of gravity. So we can say that we can actually draw another diagram. So this will be, rather, let's draw it a little bit. And then, so basically these two wires are being stretched somewhat by a length here of x. And then we have two wires of, again, force of B, and then force of A. This is the force of gravity, again. And we're going to have to evaluate this here at this instance and this instance. So let's evaluate at equilibrium first. So we have sigma f of y1 is going to be equal to 0 newtons. So 1 just signifies, just denotes rather, this equilibrium. And this is going to be f of A plus f of B minus mg. So we can say that f of A plus f of B equals mg. And then we can say that sigma f of y2, so 2 simply denotes the second scenario that we've drawn. This is going to equal f net. And this is going to equal f a prime plus f b prime minus mg. Yeah, we should further define these and say prime, because these aren't equal. The magnitude of this isn't equal to the magnitude here. So let's just, we're going to add an identifier simply. And then this is going to equal the force of A minus kx. So here it's just simply going to be equal to the force the original force minus the spring constant times the displacement. This is simply according to Hooke's law. And then we'll say plus force of B minus kx once again, and then again minus mg. So we can say that F net is going to be equal to negative 2kx plus F A plus F of B minus mg. And from the equilibrium, we know that this is going to be equal to 0. So we can actually eliminate this entire term and just say this is going to be equal to 0. So again, F net is going to be equal to negative 2kx. This is modeling simple harmonic motion with a effective spring constant, k effective, equaling 2k. So when they're asking for the frequency is simply going to equal 1 over 2 pi times the square root of the effective spring constant, so 2k, over m. So this will be our frequency. That is the end of the solution. Thank you for watching.